Hello friends, in this video we are going to study about the concept of Laplace transform. Okay, let's start. First, Laplace, what is meant by Laplace? It's a mathematician name. This is a mathematician name or mathematician. He found this transform, so that's why it's called Laplace transform. So transform, which means it is just changing one form to some other different form. Okay, it's changing something, it is in one form to some other different form, which means transform. We know that, right? So here we are going to change some functions, f of some functions, into some other different functions. Using this technique, we are going to change one function into some other different function. This Laplace transform, it has many real world applications, so many n number of applications it has. There's so many real world applications. Okay, so first we will study this concept, how to apply in the problem point of view. Finally, we will see what are the real world applications of this problem. Okay, so according to the Pearson BTech syllabus level 5 HND further mathematics, you have in LO4 learning outcome number 4, you have Laplace transform basics, those basic things. And in Tamil Nadu government engineering maths, so engineering mathematics also, you have Laplace transform in mathematics, engineering mathematics. Okay, so we will see Laplace transform problem point of view first. Okay, so what is the definition of Laplace transform? So before going to this definition of Laplace transform, let's look at some other different transforms. So differentiation, we know differentiation, right friends? Differentiation and integration, these two concepts also like transformations, because in differentiation, suppose you have one function x, you are differentiating this function with respect to x, so it is going to change 1, right? If I differentiate this function with respect to x, I will get 1. So this is one transformation, it changes my x to 1, right? So this is also transformation, it's differentiation. Integration, so I'm going to integrate this function x. So if I integrate this function, I will get x square by 2 plus some constant. Okay, x square plus 2, right? So this function x now changes into some other function, x square by 2, right? So this is also some kind of transformations. Okay, so these are, we know that differentiation, integrations, basic things. Okay, so now we are going to see definition of Laplace transform. Okay, so the definition: let f be a function. Let f be a function defined for t greater than or equal to 0, then the integral L of, this is a symbol for Laplace, L of f of t is equal to integral 0 to infinity e power minus st f of t dt. Okay, is said to be Laplace transform of f, provided the integral should converges. Provided the integral converges. Okay, so this is the formula for Laplace transform. L of f of t means f of t is any function. Okay, so integral 0 to infinity e power minus st f of t dt. Okay, now let's do some more problems used on this formula. Okay, so the problem number 1. In this first problem, I am assuming my f of t as 1. Okay, I am taking my f of t as 1. Okay, so I am going to find L of f of t. Okay, so the solution, L of f of t means, recall the formula, it is integral 0 to infinity minus st f of t dt, correct, is equal to integral 0 to infinity. Here my L of f of t means 1, integral e power minus st, f of t means 1 into dt. Okay, so 1 into anything, it's that anything value will come. So if I integrate this thing, integral 0 to infinity e power minus st dt, if I integrate this thing, integral 0 to infinity e power minus st dt. Okay, so integration of e power x, integration of e power x dx is equal to e power x, right? So integration of this thing is e power minus st 0 to infinity, right? After that, here in the place of x we have minus st, right? This is the place for x, but in the place we have minus st, so we are going to differentiate this thing, function of function rule, differentiate this thing, this power minus st with respect to t. If I differentiate this minus st, I will get minus s, right? Differentiation of t with respect to t, it's 1, so minus s will come. I have to put upon this minus s. Okay, so now I pulled out this 1 by x outside of the bracket, so e power minus st 0 to infinity. Now I have to apply upper limit minus lower limit, so minus 1 by s, so e power, in the place of t I have to substitute this infinity, minus e power minus s into 0. Okay, so minus 1 by s, so s into infinity, s means any constant term. Okay, so e power infinity minus s into infinity, it's e power minus infinity, minus e power 0 into anything, it's 0, right? So it's minus 1 by s, e power minus infinity, recall e power minus infinity is 0, e power plus infinity means it's infinity. Okay, e power minus infinity it's 0, e power plus infinity means infinity, e power minus infinity is 0, anything power 0, it's like anything power 0 is 1, right? So minus 1, so minus into minus plus 1 by s, correct friends? Yeah, so L of f of t is equal to 1 by s. What is my f of t here? 1. So L of 1 is equal to 1 by s. So Laplace transform of 1 is 1 by s. Got it? I hope you understood. Okay, so L of 1 is 1 by f's. First I took the value f of x, the given function f of t is equal to t. I substituted the function t f of t here, and I applied normal integration method. Okay friends, so L of 1 is 1 by s. Let's do one more problem. So the second problem is integral so f of t is something e power at. Okay, e power at. So I have to find Laplace transform of f of t. So we have to find this value, right? So the solution, so what is the Laplace transform of f of t? We know the formula, integral 0 to infinity e power minus st f of t dt. Okay, so for here the given f of t is e power at, and I'm going to substitute here e power minus st, f of t means e power at, I substituted the given f of t value, so dt 0 to infinity. Now I'm grouping these two values, so e power minus s plus a into t, right? So if the two bases are same, I can add the powers, right? So using that idea, I added these two values, minus st plus at. So I took this t common, so I pulled out this t outside of the bracket, so dt. Okay, so now I'm going to integrate this function, right? So it's like e power x, right guys? So e power x is, it's e power minus s plus a to t correct? E power x is, it's like e power x, e power x is integration, e power x is e power x. So but in the place of x we have minus s plus a into t, so I have to differentiate this function again. So if I differentiate with respect to t, I will get minus s plus a only. So I have to put this minus s plus a upon this e power minus s plus a into t. Okay, so it's 0 to infinity limit. So 1 by minus s plus a. So first I have to substitute in the place of t upper limit. So e power minus s plus a into infinity minus, in the place of t I have to substitute the lower limit. T into 0, it's 0 into anything, 0, right? So it's e power 0. So 1 by minus s plus a, so it is again e power infinity, right? So it's, if you took, listen here I am going to take minus term common. Okay, so minus common, so it is s minus a into infinity minus 1, right? Y means if I multiply these two things, I will get e power infinity. E power infinity is infinity, so infinity of full term, it's infinity. So this L of Laplace transform of e power at, it's undefined, it should be indeterminate form, some other different, it is infinity, so it is not valuable. So that's why for that complication I took this, I pulled out this minus outside. Okay, so now I'm going to multiply these two things. If I multiply these two things, I will get minus infinity, right? So e power minus infinity, it's 0. So for simplification I'm going to write this thing a minus x. So e power, it's minus infinity minus 1. So 1 by a minus s, so e power minus infinity is 0 minus 1. Okay, so this thing, it's okay, so minus 1 by a minus s, correct guys? So this is the formula for Laplace transform of e power at minus 1 by a minus s. You can write like this, or Laplace transform e power at is equal to 1 by, I am moving this minus to the denominator. If I move this thing, 1 by s minus a. Okay, you can write like this or this one, anything, it's fine. Okay, so this is e power at. Similarly, if I change my f of t as some other functions, sin at or cos at or something, sin h at or cos h at or t, just t square or t power n in general form, like this, I can change the functions f of t, whatever I want I can change the f of t. So okay, if I change, I'm going to apply the same f of t Laplace transform formula again for this above functions also. If I apply this thing, I will get some other functions, for respective functions I will get some other different Laplace transform formula. So I'm going to give those functions as exercise to you. Okay, so if I applied all those things, I will get formulas like this. So elementary, standard, linear, Laplace transforms. So my function f of t, so this is the L of f of t formula. If I apply 1 in the, if I took f of t as 1, means my function is Laplace transform is 1 by s. If I took k, means it's k by s. It's e power at means 1 by s minus a. This thing we already solved, right, in this video. So similarly, if I apply sin at, I will get a by s square plus a square. Cos at means s by s square plus a square. T means 1 by s square, and t square means 2 factorial by s cube, and t power n. I'm just grouping, generalizing these two things. Okay, here, so n means it's n factorial by s power n plus 1. Then cos hyperbolic function and sin h hyperbolic function, I will get these two Laplace transform for the respective functions, different functions. Okay, so now you have to, no need to memorize all those formulas, because you know how to produce these, how to produce all the formulas, right, using this definition. So no need to memorize all those formulas. You can derive the formulas. So that's why I took these two things. I taught these two things to you. Okay. So next we are going to solve some problems, Laplace transform problems using these formulas. Okay, using these formulas. So let's do some problems. So before going to that one, we have to know linearity property. Linearity property of Laplace transform. So linearity property, it is also hold for Laplace transform. So suppose Laplace transform of a f of t plus b into g of t is equal to a times Laplace transform of f of t plus b times Laplace transform of g of t. Okay, so I can pull out this a and b are constant terms. I can pull out these two terms outside of the Laplace transform. Okay, so I can separately do these two f of t and g of t separately. I can able to do. So this is linearity property. Laplace transform will satisfy this property also. Okay friends, so now let's do some elementary functions Laplace transform. So the first problem number 1, find the Laplace transform of the following functions. Okay, so the first function is, I'm taking the function is 1 minus t by 3 plus e power 2t. Okay, so I'm going to apply the Laplace transform concept for this function. Okay, so the solution. So Laplace transform of this function, Laplace transform of 1 minus t by 3 plus e power 2t is equal to, so Laplace transform will satisfy linearity property, right? So using this property I can push this L inside this bracket, curly braces. So L of 1 minus, it's 1 by 3, right? So I can pull out this 1 by 3, L of t plus L of e power 2t. Okay, so I will do here Laplace transform of 1 by the formula. Where is the formula sheet? Okay, here only. By the formula, Laplace transform of 1 is 1 by s. So I am going to use that one. Laplace transform of 1 is 1 by s minus 1 by 3. Laplace transform of t is, what is the formula? Laplace transform of t, t is 1 by s square. So 1 by s square plus Laplace transform e power, it's like at, right? So instead of a we have 2 here. So e power at, where is that? Here. Instead of a we have 2 there, right? So 1 by s minus 2, we have 2 here, right? So 1 by s minus 2. So the answer is 1 by s minus 1 by 3s square plus 1 by s minus 2. So this is the Laplace transform of this function. Have you understood? So this is the Laplace transform of this given function. Okay friends, now let's see some more problems in the Laplace transform. Let's do one by one. I'm not going to do all the problems, okay? So I will do some more problems, only a little bit difficult problems. I'm going to give some more problems to you as homework, okay? Okay, so solution. So this problem and this 4 problems I'm going to give as exercise to you, because these are very easy problems. You can use this formulas of Laplace transform easily apply, can able to easily apply to these functions. Okay, So this one and this one's little bit complicated, like sine square t. We don't have any formulas based on sine square t, and we don't have any formulas based on cos h square s 3x. So let's do these two problems now, and later if we have a time I will do one problem. Okay, not all the problem, only one problem in this whole one. Okay, so the first one is E, sine square t. So according to trigonometry concept, we know one formula. Sine square x means 1 minus cos 2x by 2. This is the formula from trigonometry. Okay, so sine square x means 1 minus cos 2x by 2. So here we have t. So this function is full of involved t. Sine square t means 1 minus cos 2t by t. So I have to find the Laplace transform the given functions. So L of sine square t means L of, this is a simplified form of this sine square t. So 1 minus cos 2t by 2. Now I can split this denominator for 1 and cos 2t separately. L of 1 by 2. So I'm going to apply the linearity property here. So L of 1 by 2 minus L 1 by 2, I'm taking outside 1 by 2 and cos 2t. Correct? I'm just multiplying, okay. L of 1 by 2 minus L of cos 2t by 2. Okay, so L of 1 by 2, correct? So it is a constant term, so I can pull out this term also outside. 1 by 2 L of 1 minus 1 by 2 L of cos 2t. So 1 by 2, Laplace transform of 1 is what? It is 1 by s minus 1 by 2. Laplace transform, it looks like cos at. So recall the formula. L of cos at means s by s square plus a square, right? So s by s square plus, here a means here we have 2, so 2 square is 4. That's all. This is the answer. So 1 by 2s minus s by 2 into s square plus 4. So this is the Laplace transform of given sine square t. I hope you understood, guys. I didn't do something new technique. I just applied the trigonometry formula and apply normal Laplace transform concept only. Okay, so next we will do cos h square 3x. So okay, this thing, so cos h square 3x, correct? So in the hyperbolic functions we have one formula. What is that? Recall, it is cos h2x is equal to 2 cos h square x minus 1. This is the hyperbolic formula, one of the hyperbolic formula. Cos h square 2x is equal to 2 cos h square x minus 1. So here we have cos h square 3x, so it's like this one, right? So I'm moving this one that side. So cos h2x plus 1 is equal to cos h square x by 2. I moved this 2 also this side. Okay, so it is in multiplication here. If I move this side, it will be division. Okay, so cos h square x is equal to 1 plus cos h 2x by whole divided by 2. Okay, so this is the formula now. Here we have, instead of x we have 3x, right? So I'm going to change here. Cos h square 3x is equal to 1 plus cos h 2 into 3x, correct? By 2. So 1 plus cos h 6x by 2. So cos h square 3x means it is 1 plus cos h 6x by 2. Okay, so cos h square 3x, instead of cos h square 3x I can write 1 plus cos h 6x by 2. So we want to find cos h square 3x only, right? So cos h square 3x, so instead of this thing I can write this one, 1 plus cos h6x by 2. So I'm splitting this 2 for this one and this thing separately. Laplace transform of 1 by 2 plus h6x by 2. So now I am going to apply the linearity concept. So Laplace transform of 1 by 2 plus I'm going to pull out this 1 by 2 out. Laplace transform of cos h6x. So here also I can pull out this 1 by 2 outside. So 1 by 2. Remaining thing is Laplace transform of 1 plus 1 by 2. Laplace transform of cos h6x. Correct? So this is the 1 by 2 Laplace transform of 1. So I will show here. Okay, now it's right. So 1 by 2 Laplace transform of 1 plus 1 by 2 Laplace transform of cos h6x. Correct? Yeah. Okay, so this is 1 by 2. Laplace transform of 1 is 1 by s. Correct? We know the formula. Laplace transform of 1 is 1 by s plus 1 by 2. Laplace transform of cos h(ax). What is the formula? 1 minute. Recall. Laplace transform of cos h(ax) is equal to s by s square minus a square. This is the formula. In the place of a, we have here 6. So s by s square minus a means we have 6, right? 6 square. What is 6 square? It is 36. That's all. So the answer is 1 by 2s plus s by 2 into s square minus 36. That's all. This is the Laplace transform of, where is the question? Yeah, it's here. Cos h square 3x. Got it? First, I applied the hyperbolic function formula. So that is cos h2x is equal to cos h square minus x, h square x minus 1. I want cos h square x only, so I kept it in the right hand side. I moved all those things to the left hand side. So this is cos h square is equal to x square x equal to 1 plus cos h2x by 2. So finally I want cos h square 3x. Here I have cos h square x only. So in the place of x, I am going to substitute this 3x. So if I substitute 3x, I will get 1 plus cos h2 into 3x by 2. Correct? Yeah. So cos h square 3x is equal to 1 plus cos h6x by 2. So instead of cos h square 3x, I can write 1 plus cos h6x by 2. Correct? Yeah. So Laplace transform 1 plus cos h6x by 2. Now I am applying that linearity concept. So Laplace transform of 1 by 2, I can pull out this outside. Laplace transform of 1 by 2. So cos h6x. Okay. So I am going to use this formula. Laplace transform of 1 is 1 by calculate. Finally you get this thing. Got it? Okay, super nice. So let's do one more problem. So here we done this one and this one, it's over. So in this 4 thing, I'm going to do this D. So these 3 problems I'm going to give to you as exercise. You guys just try to solve this problem. So now I'm going to do this D, 5 e power 2t minus 3 e power minus t. So okay, I have page D. Okay, so 5 e power 2t minus, what is the question? 3 e power minus t. I have to find Laplace transform of this function. Okay, so the solution, let's start here. So Laplace transform of 5 e power 2t minus 3 power minus t is equal to, so now I'm going to apply this L to all those functions. Laplace transform of 5 e power minus 2t minus Laplace transform of 3 e power minus t. So now I can pull out this 5 outside. So 5 Laplace transform of e power 2t minus 3 e power minus t. So recall the formula. What is the formula? So Laplace transform of e power at is equal to What is the formula? E power 8 is equal to 1 by s minus a, right? Yeah. So this is the formula. 5 into, so in the place of a we have 2 here. So I'm going to substitute 1 by s minus 2. S minus 2. Correct? Minus 3. So 1 by s minus, in the place of a have minus 1 here. So s minus 1. Correct? Yes. 5 into 1 by s minus 2 minus 3 by minus into minus plus s plus 1. So it is 5 by s minus 2 minus 3 by s plus 1. Correct? So this is the Laplace transform of this function. Okay. So that's all the Laplace transform basic things. Okay, so in the next video we'll see some more different functions based on the Laplace transform and inverse Laplace transform, those things. Okay, thank you friends. Like the video, share the video and comment video.